Find the value of k for which y equals minus 2x plus 1 is tangent to y equals x squared plus x plus k. Here we see the graphs of y equals minus 2x plus 1 and y equals x squared plus x plus k, where k has been chosen so that the line is tangent to the curve as we require. The quantity k is the intercept on the y-axis of the curve, and it is this value, the displacement from the x-axis, as shown. At the point where the line and the curve are tangent, they have the same gradient and they intersect at a single point P. We first find the gradient of the line and the curve at the point at which they intersect. Now we immediately see that the gradient of y equals minus 2x plus 1 is m equals minus 2, and to find the gradient of y equals x squared plus x plus k, we find dy by dx for that function. So we have that dy by dx equals the derivative of x squared, which is 2x, plus the derivative of x, which is 1, plus the derivative of k, which is 0. So dy by dx equals 2x plus 1. So the line and the curve have the same gradient when dy by dx equals m. So we set 2x plus 1 equal to minus 2, and we solve that equation to find that x equals minus 3 over 2. Which tells us that the curve and the line have the same gradient where x equals minus 3 over 2. We now use the fact that the curve and the line intersect at a single point. Since the point P lies on both the curve and the line, its x and y coordinates must satisfy both equations, the equation for the curve and the equation for the line. We first use the equation for the line. Now since x equals minus 3 over 2, from the fact that y equals minus 2x plus 1, we have that y equals minus 2 times minus 3 over 2 plus 1, from which we find that y equals 4. And so the curve and the line must intersect at minus 3 over 2, 4, as indicated on the graph here. We now use the equation for the curve. We know that y equals x squared plus x plus k, and we know that x equals minus 3 over 2, y equals 4, satisfy that equation. And on substituting those values into the equation, we have that 4 equals minus 3 over 2 squared plus minus 3 over 2 plus k. And we solve that equation to find that k equals 13 over 4. We used calculus to solve this problem, but we now show a different method, one which relies on the properties of quadratic equations. Find the value of k for which y equals minus 2x plus 1 is tangent to y equals x squared plus x plus k. Now a line is tangent to a curve if they intersect at one point only. So here we see a picture of a quadratic and a line which intersect at 2 points. Now for a quadratic, the value of the constant term, which in this case is k, determines the intercept on the y-axis, i.e. the value k shown here. And for this particular value of k, the line intersects the curve in 2 points. So this is not the situation that we require. On the other hand, in the lower blue box, we see the curve with a different value of k, and in this case, the line and the curve intersect at 1 point. So this is the situation that we are looking for. To find the points of intersection of a curve and line, we solve them as simultaneous equations. So our simultaneous equations are shown here. Y equals x squared plus x plus k, y equals minus 2x plus 1. And it's clear that we will produce a quadratic equation, and for that quadratic equation we need only one solution for x, because that is what corresponds to a single point of intersection. And in the lower blue box we can see the appropriate value of x. Bear in mind, however, that we do not need to find the value of x, we need to find the value of k that gives us a single solution. Now, given our simultaneous equations, we form the single equation x squared plus x plus k equals minus 2x plus 1, which rearranges to give us x squared plus 3x plus k minus 1 equals 0. And now we apply the condition that forces a single solution in x to that equation. And that is that the discriminant of the quadratic equation, which is the quantity b squared minus 4ac, is equal to 0. For the quadratic equation in question, we have that a equals 1, b equals 3, and c equals k minus 1. And on substituting those values into the discriminant, we find that the required condition is that 3 squared minus 4 times 1 times k minus 1 equals 0, which we solve as follows. To find that k equals 13 over 4.